Sure. Okay. Okay. Yeah. So we will now implement a countdown timer. Okay. So while num greater than hmm, greater than or let's say equal to zero, we'll display zero also. Print num. Okay. Um, print num. We display the number. After that, after displaying the number, we will reduce it by 1. Num minus is equal to 1. Okay. So let's save the program and now run. User is being prompted to enter a number, let's say 6. Okay. So it displays the value 6543210. Okay. Let's put a print statement. Print countdown timer elapsed. Okay. So if we enter a number something 43210, and then it says countdown timer elapsed. Okay, but here the values are being displayed almost instantly. Okay, 43210, and then it displayed the message countdown timer elapsed. So what we would want is, if it want to appear like a timer, we want a delay. Okay, it should display 4. Maybe after 1 second it should display 3. Similarly, after 1 second it has to display 2, and so on. So to introduce delay in our programs, okay, we can make use of a method or function called as sleep, which is there in the time package. Okay, so what we'll do is, every time after displaying the number and reducing it by 1, we will use the sleep function, time.sleep, which takes seconds as the parameter. Okay, so if I give 1, it is considered as 1 second. So what it will do is, it will suspend the execution for 1 second. Okay, so thereby acting like a delay. So let's see this program. Let's see rerun the program. Okay, let me enter 4. So it displayed 4, 3, 2, 1, 0, and the countdown timer has elapsed. Okay, so now we are getting a delay between successive values. Okay, maybe for this to look better, let me add a tab character at the beginning so that it's visible. Okay, run, enter a number 4, 43210. Okay, and it displays countdown timer elapsed. Now another thing is, we just want this countdown timer to display values at the same position. Okay. Uh, okay. Are you able to see the program output? Hello, Disha,
Yes, sir. Yes,
Tanmay.
sir.
Okay, you're able to see this, right? Okay. So do type this program. Also, you could also do it parallelly along with me. Let me know once you're done. Tanmay, can you hear me? Can you reply in the comment box? Hello, Tanmay, you can hear me now? Okay, Disha, did you finish the program?
Yes, sir.
Yeah, okay. Okay. So now we introduced delays also. But like after displaying a particular number, we want to clear the screen as well. Okay. So for that, we have uh, the sys package. So we use sys dot, sorry, not the sys, I think OS package. OS dot system and clear. So in this clear command works on Linux. If you're using Windows, maybe you have to use CLS instead of clear. Whatever command you use for clearing the screen, yeah, you should use it here. Okay, instead of clear, try using CLS if you are using Windows. Otherwise, you can use clear command. Okay, let's rerun the program. Let me enter a number 5. Oh, okay. I have to use this clear command carefully. Control X. Yeah, I think the order matters. Okay. Okay. And Okay. Uh, so let's give a number as input: 4, 3, 2, 1, 0, and then it says countdown timer elapsed. So let's try to understand what is happening here. Were you able to see the output? How the countdown timer worked?
Yes, sir.
Okay, okay, fine. So where was it? So we have two packages, time and OS, being used in a program. Time is used for introducing delays using the sleep method, and OS is for running a command using the system method. The command that we are using is the clear command. Okay, did this clear command work for you, Disha?
Sir, it did, but when I put it before the then statement, then I don't get. Wait, I'll just try again.
No, I guess say like you are using an IDE, it you may not get it properly if you run it from the command line or something like that. Maybe that's why I too. I guess in my case also here the output was not visible. Oh no, okay. Yeah, put a new line maybe. Then you may see it.
Yes, sir, I'll try that.
Yeah,
Yes, sir, I got it.
yeah. Okay. Okay. So here we are first clearing the screen. Okay, so to display to remove output from any of the previous yeah, okay, I think now the screen is visible. uh, so what we do here is we ask the user to enter the number, then as long as it is greater than or equal to 0, then the following instructions are run as part of the loop. So the condition is as long as num is greater than 0. First instruction is os.system. We want to run some command. We can make use of the system method os.system, and in this case we want to the command to be run is clear. Okay, so if I use ls here instead of clear, it will return the list of files in the current directory. Okay, like that. You can run any command using the system method. After that, okay, just to make the output visible in a proper form, what I'm doing is I'm printing two new lines. Okay, slash n is like your enter character. Okay, so it takes the cursor two lines ahead. Slash t is like your tab character, so it gives a tab space from the beginning of the line, and then we are displaying the value of num. After displaying the value of num, we reduce the value by 1. Okay, after that we introduce a delay of 1 second, time dot sleep 1. Okay, if you want a delay of 2 seconds, you can say time dot sleep of 2, something like that. And once the loop finishes execution, once when a number becomes 0, okay, it will run for the last time. After num is reduced further, num becomes minus 1, in which case the while loop fails. And the um, while loop is terminated, it goes on to the last line, executing countdown timer elapsed. Okay. Okay. The next example we will look into is the while loop, nested while. Okay. Num is equal to eval. Disha, Disha, can you hear me?
Yes, sir.
Yeah. Okay. So type the code along with me. Fine. Disha, let me know when you're done.
Yes, sir.
Yeah. Okay. So what we are doing in this program is uh, we are illustrating the nesting of loops. Okay, especially with the while loop. So within the body of a while loop, can we place another while loop? The answer is yes. Yes, you can place one while loop within another while loop. Okay. So which is what we have tried to illustrate in this particular program. So I want to print a matrix of this asterisk symbol or something like that. Okay, you can choose any particular symbol of your choice. Okay. So I want to display. So whatever, if the user enters a value n, I want to display a matrix of size n star n. Okay, and all the entries in the matrix will be this asterisk symbols. So what we have to see here is obviously this is a repeated operation. Okay, where I want to print four rows. Okay, we can see this as printing n rows in general, but if you look at printing one row itself, within the row itself, we have a repeated activity. Okay, so we come across nesting when we have a repeated activity performing a particular task, and if this task that is repeated in itself has a repetition, okay, repeated operations, then we will have an inner loop also. So what we can say is the outermost task is that I have to repeatedly display a row of asterisks. Okay, so how many rows? As many as the user has given as the input. Okay, so in this case it was four, so we have to print four rows. And is the row printed in a single go? No, it also requires repeated operations where I display multiple asterisks in a single row, which is a repeated operation. Okay, so let's see how this works. So I is equal to 0. We set I to 0. As long as I is less than num, okay. So this body of the outer while loop executes. So the body of the outer while consists of these statements. Initially, to start with, let's say n is 4, I is less than 4 is true, 0 is less than 4 is true. And next, so this would run n times. Okay, 0, 1, 2, 3. If n is 4 or num is 4, it would run for I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3. When I becomes 4, it stops. Okay, so this is for the outer loop, which runs num times. The inner loop also has to run num times, but for that I have to use a different counter. For the outer loop, the counter is I. For the inner loop, the counter is j. Okay. So similarly, j also, if I use the same condition, j less than num, so this also starts from 0. J is equal to 0, j less than num. So this will also run n times. Okay. So every time, what I have to do is I'm printing the asterisk character. Okay. And another thing is we have to change the default behavior of print. So if I don't specify this end is equal to slash t, what happens is print by default after printing anything will add a new line as the end character. Okay. So if let's say I have not used this, let's see what happens. Okay, I will give a small value 3. Okay. Disha, what did you observe now?
After three times, he'll repeat to the next line.
Next line, but like after every asterisk, what are you saying? It is moving
It
to a
go-
new line because by
yes.
default slash n will be added at the end of every print statement. Okay, so it printed an asterisk. Okay, for j is equal to 0, j is equal to 1, j is equal to 2, but not in the same line, but in newer lines. Okay, so to change that, we have to say, okay, don't use new line as the end character. Instead, use a tab. Okay, you can specify what character should be used as the end character. So I have set it as slash t. Okay, so this time let's run the program again. I gave 3. Okay, so this time what it does is it prints star and then prints a tab character. Okay, so this so the cursor will come here. J will be 0. J plus is equal to 1 makes j the value is 1. 1 is less than 3. So it prints another asterisk and then the tab character. J is incremented, j becomes 2. 2 is less than num. Yes, the condition is true. So it prints the third asterisk and also prints a tab. Okay, it has printed as tab character here. J is incremented again, j becomes 3. Okay, 3 is not less than 3. So the inner while has finished its execution. Okay, it comes out of the while and goes on to the next instruction, okay, which is print. So if I give a print statement, what do you expect this print to do? What is it doing?
Goes to the next line.
Why?
Because
It
it's
does go to the next line because it doesn't print anything. Okay, but by default the behavior is that it prints an end character which is slash n. That's why it goes to the new line. Okay, print will print and the cursor will come at this point. I is incremented. Okay, I which was 0 now becomes 1. Okay, we so the condition is checked here. Okay, well, 1 is less than 3. Yes, the condition is true. Next, j is reset to 0. Okay, j had become 3. Now, when it comes for the second iteration of I, j again is set to 0. 0 is less than 3, so it prints a star and a tab. Okay, j is incremented again to 1, like that 0, 1, 2. When j becomes 3, this while loop fails. We have a print statement. It brings the cursor to the next line. I is incremented, I becomes 2. 2 is less than 3. Control enters the loop again. J is reset to 0. In the same manner, this while loop will print 3 asterisks and print the enter a new line character here using print. I plus 1 will make I also 3 now. So 3 is not less than num. 3 is not less than num, and therefore uh, the outer while also fails and we stop. Okay, so now
yes.
uh, we will see other patterns, how we can print other patterns. Okay, mm, let's say that I want to print alternative zeros and ones. Okay, instead of star, my matrix should be printing zeros and ones. Okay, so can you think of something that can do that operation? Okay, instead of print, I should print 0 or 1.
So should the 0 and 1 be random, or should there be an order?
No, no, no. Alternative. One time 0, one time 1. See if you can establish a relationship between the values I and j. Oh, another thing, I and j can also act like indexes. See, for the first asterisk, what is the values of I and j?
1 and 1.
1. Is it 1? Have a look at the program. Where is I starting from?
Oh, 0.
0. Okay, so this is 0 and 0. I is 0, j is 0. Okay, here I is 0, j is 1. Here I is 0, j is 2. Okay, so it is 0 to n minus 1, not 1 to n. Okay, it is 0 to n minus 1. Okay, you can start from I is equal to 1 and you have to write the condition as less than or equal to. Okay, so there, then also you'll get the same result. Here we have used 0 usually. Okay. uh, can you establish a relationship to this position with I and j so that they become 0 and 1?
So we can like use the matrix formula. So if you add them and then
Huh.
if it's divisible by 2, then we can make it as 0.
Huh.
If it's not
Right,
divisible,
right.
we can make it as 1.
Yeah, so if I plus j is even, display 0, otherwise
1.
display 1. Okay, or you can just write it as an operation here. I plus j, what should we do? Mod 2. What will be the result of mod 2?
Um, is equal to 0.
0 or
1.
when you do a when you do a remainder operation by 2, the result will be either 0 or 1. Okay, so what I do, I add up I and j and then perform mod 2. So initially 0 plus 0 mod 2 will give me 0 itself. Okay, so it will print 0. Next time 0 j will be 1, 0 plus 1 is 1, 1 mod 2 will be 1, it will print 1 and so on. Okay, let's see. Let me give 3. Okay, did you understand this?
Yes, sir.
Hmm? You can even write a if statement also instead of that. If I plus j mod 2 is equal to 0, print 0, end is equal to slash t, else print 1, end is equal to slash t. Like that also, you can write a if condition, or you can use this modulo operation also. There are multiple ways to achieve the same result. Okay. Um, okay. So, let me copy this, control C. I will put here. Okay. Uh, let's say I want to print an asterisk. I will use the same code. Okay, for the time being, let me comment this part. Yeah. But here, instead of j less than num, I will make it the condition as j less than I. Run this program and see what is the output that you get.
I get a diagonal matrix.
Diagonal matrix, right? Yeah. So if I give 4, okay, we get a diagonal matrix of 3, size 3. Okay. If I make it less than or equal to I, and this time I enter 4, we'll get a matrix of size 4 itself. Got it?
Yes,
Okay.
sir.
Now, one last thing. I want the diagonal elements to be containing asterisk. Okay. Bottom elements of the diagonal elements should be plus, should be minus. Upper element should be plus. Right, write the code for that. Try writing code for it.
So the lower one should have asterisks. the middle one should
No, no,
have.
no, no. Diagonal should have asterisk. Okay. Lower minus symbol. Okay. Upper plus symbol.
Okay, sir.
Lower diagonal elements minus 1, upper diagonal elements plus 1. So what will be the idea?
So we use if statement here, and then
Huh. What
uh,
conditions? What conditions will you use? On the diagonal, which condition is satisfied?
we can use mod again.
Mod or no, look at the diagonal values here in any matrix. What will be their index values? What is the index of this?
Will be
I and j values will be what?
0 and 0.
Here,
Uh,
next iteration, I will be 1, j will be 1.
yeah.
Here, I will
So
be
if
2, j
it
will be
has,
2. So, what is the condition?
it needs to have
So,
the
what is the
same.
condition? Huh. So,
If
what
I
condition
is equal
will you write here? If I is equal to j. Okay. In that case, we will print asterisk under tab. Then, what else should we write? Elif. What are the other two possibilities?
I
See,
guess
this
now.
is 0, 0. Hello.
Sorry, sir. Continue.
Elif, what condition should I write? I, if I is less than j. Okay.
Sir, I think here
That
we can do even and odd
even and odd. Why even and odd?
because, like, in the first line, second
Are
one,
they even? Huh.
yes,
So
I
all do all these lower diagonal elements are either odd or even, something like that? Do you say?
I think so. I'll just check once again, sir.
Yeah. Okay. The other property could be like always here I will be less than j. Here I will be sorry. I will be greater than j in the lower diagonal. I will be less than j in the upper diagonal elements.
Yes, sir. That's easier.
You can use that property also. Yeah. Print and then I can write else. If it is not equal to, if it is not lesser, it obviously will be greater. I print a different symbol. Okay. Oh, I think I have to exchange these values. Plus, yeah, I told it, but I while coding I used a different value. 4. Do you see the output now?
Yes, sir.
Okay. Okay. So we'll look into similar examples of patterns when we look into for loop as well. Okay. So next, okay. One last assignment. Okay. Write a program. I write a program for the following. A city has a population. A city has a population which is increasing, which is increasing annually, which is increasing annually at a growth rate, at a growth rate, growth rate R. Okay. Earlier, let's say we consider the population to be P. Find out how many years, find out how many years it takes, it takes for the population to double. Okay, did you get the question?
Yes, sir.
Okay. So let's take an example. Suppose we have a city whose population is 150. Okay, let's assume. And the city's population is increasing at, let's say, 10%. Okay. So uh, at the end of the first year, how many people are added to the population? What is 10% of
165.
150? Huh. So 15 people are
165.
added. So the, yeah, so the population will be 165. Okay. So next year, 16.5 gets added. Okay, like, because it is population, we will say 16 people are added, something like that. Okay. So like that, I want to find out how many years it will take for the population to double. Okay. So here, population and growth rate are given as input from the user. So write those instructions for reading the current population and the rate of interest. Tanmay, you share your screen. I'm stopping here. Yeah, enter current population. Correct. Okay. So
So
what are we
now
supposed to find out?
we
What
need
is
to
to be
find
found? We find the
years.
number of years, right? Okay. So
Exactly.
initially, years will be 0 to start with. Okay.
while P
Hmm.
is equal
What
to,
condition will you say?
will that work?
Two, two star P, no?
Oh yeah, sorry.
Huh. But here you can't use P for both the things. Okay, if you write P equal to 2P, it will never be right. Okay. At the end of every year, the population will change. So what we'll do is we will take
Yes.
another variable called new population. Okay. So to begin with, what will be the new population at the starting?
P.
P. Yeah. So
So
set up
X
that.
will
Set a
be,
variable
yeah.
not 2 star P. Like if you call it X, it should be P.
Okay.
Okay.
Yes,
So
sir, I got it.
as long as what why I don't think so is required. Oh, why the number of years, right? Okay, fine. Okay.
Yes.
So what will you write here?
While P
What is
is
the
equal
relation
to,
between X and P equal to
no, X is equal to 2X. If we do that, will that work, sir?
see, we want to say keep repeating as long as this condition is true. So till when we are repeating the condition, as long as the population is lesser, we keep on doing the new population computation. Okay, so what you should write, well, till the population is lesser than two times, as long as population is less than, sorry, new population is less than what?
Um, the old one,
Less than or
current
equal
one.
to current population. Yeah, write that condition. New population is what? X, right? X is less than or equal to two times
P.
P. Okay. Hmm. Okay, you should use for the time being. It's okay, but when you write programs, write meaningful variable names. Okay, X and Y, they are not pretty much obvious. Okay,
Yes, sir.
population also you could write population and so on. Okay, fine. As long as the current population, sorry, the new population is less than or equal to two times the current population, initial population, not the current population. Okay. So what do we do when this condition is true? We have to calculate the new population. Okay. How do you calculate the new population?
Um,
You
so
have to use
so
the growth rate.
yes, sir.
Okay.
So it'll be X equal to
You have to find out the increment first. Okay. How many people get added, and that you have to add to the new population. Suppose say there are 200 people and I say rate is 20 people. Okay, then you get to know, okay, the number of people added will be 20% of 200.
that'll be 40.
Huh. In the case of 200 it will be 40, but you have to write this in terms of population.
So it'll be um
Huh.
P into
P P caps, you have to write capital P because you have capital P, you have used capital P earlier. Okay. Yeah.
I'll make it small.
No. Anyway, you have then you have to change it at two places. Keep it consistent. That's all. Whatever you use. Okay, p multiplied by,
R divided by 100.
correct. Yeah. So it could be possible that this increment could be a fractional number, but saying
So we
that
need to
2.5 p increase, that doesn't make sense.
we use integer.
You have to use integer in this case, not eval. Eval will give us the numerical result itself. It will take the precision also. You have to use int,
Yes.
right? Okay. Okay. So what is the new population in, equal to now?
So x is equal to
Huh.
x plus.
Huh. So you can write it in the shorthand form, no? X plus is equal to, press enter. That's all. Okay. And then what is was the one more computation you have to do
Um,
after every year?
and then y plus 1. Y is equal to
Yes,
y
yes.
plus 1.
Y is equal to y plus 1, or shorthand form again. Y plus is
And,
equal to 1. Hmm. So is there any other thing that we have to do in the loop?
uh,
That's all.
yes,
Okay.
sir.
Okay, so every year we'll calculate the increment and add it to the current population. We will increment the year by 1, and then we will again check whether this new population X is actually reached twice the population or greater. Okay, so when the population exceeds 2p, okay, then while loop terminates. Next, print the result.
So it shouldn't include the loop, right, for this one?
Print statement should not
The
include,
print
right? You will
statement.
print it only once.
Yeah.
Yeah, the result will be
Yes,
printed
sir.
only at the end. Yeah.
Hmm.
It took these many years to double, something like that.
Okay.
Something like that you can print. It took, and then y, hmm, years for the population to double. We can also print the latest population as well. Okay. So you can stop sharing now. Okay, can you see this code?
Yes, sir.
So it's
Yes.
almost the same. So instead of increment, what I have done here is I have put it in a single statement. Okay, 1 plus rate by 100 multiplied by 1 plus rate by 100. So if the growth rate is 10%, it will be like multiplying by 1.1. Okay, say suppose the population is 150, rate is 10%. So then 1 plus 10 by 100 is 1.1. So 150 into 1.1, which gives me 165. Okay, it's also the same. Or you can write this as separate, like you can calculate rate by 100 into population and then add it to the population. Okay, so both of them should be the same.
Yes, sir.
You can run the program, give some input, and see as to whether it works or not. Okay,
Yes, sir.
nested loops, multiplication table. Okay, so now let's come to the for loop. Okay, so usually in most of the while loops that we looked at, we wanted to run a task uh, repeatedly as long as some condition is true. Okay, so the number of times the task is repeated need not be the same because it is dependent on a condition. Okay, we don't know beforehand how many times a particular while loop executes. For example, the population program itself. So will it be that the while loop runs exactly the same number of times, no matter what the input is?
No, it changes
No,
according to
right?
the.
Yeah. Say for example, if my growth rate was higher, what will happen to the number of times the while loop executes?
It'll reduce.
It will reduce, right? Okay. Similarly, if I take a smaller growth rate, so
Increase.
it will increase the number of times. So basically, the thing is, most cases when we run a while loop, we don't know beforehand as to how many times we have to run a repeated task. Okay, but we know that okay, this task should be repeated as long as some particular condition is true. Okay, once that condition fails, stop. That is one scenario. But sometimes we would want a particular task to run for a specific number of times. Okay, say for example, I want to display a multiplication table. Okay, so how many times would you want it to run?
10 times.
10 times, because the multiplication table will have 10 entries. Two ones are two, two threes are four, two threes are six, something like that. Okay. Uh, so in such cases, we make use of the for loop. Okay, for loop is when we know beforehand that we want to run a particular repeated task a specific number of times. Okay, so the syntax of the for loop is we use the condition for iterator in iterable. Okay, and then we will have the body of the statement suite. Okay, it suite consists of a set of statements that are run as part of the for, and here also all the instructions that should be repeatedly executed should be written at one tab. Okay, let's try to understand what we mean by a iterator and a iterable. Okay, so iterator is something that can be repeatedly executed. Iterable is a collection of elements. Okay, so we want to run this iterator over that particular collection of elements. So let's see an example. Okay, here only I will type a for loop for and let's use the new one only. Uh, for loop demo, for loop demo.py. Okay, for if I in range hmm, for I in range, then print I. Okay, so the general format we said for loop. We have a iterator. In this example, the iterator is I. Okay, you can choose any name for your iterator. Okay, and this iterator, for iterator to work, you should specify a iterable which is a collection. Okay, and we use the keyword in. Okay, so how this works is it picks up element sequentially from the iterable. Okay, starting with the first element, and it will store that first element into I. Okay, and it will execute the body of the statement. It will then next time go on to pick the second element in the iterable and then go on to do the operations. Okay, so range is again a built-in function. Okay, so type range 10 in your console. Help on range. Okay, Disha, can you see this output here?
Yes, sir.
Okay, so what the range function does is it gives us an object that produces a sequence of integers. Okay, so range has three possible forms. Okay, you can give just a single value, you can give two values, or you can give three values also. Okay, we will look at each of those examples. Okay, so if only a single value is given, it is taken as stop. Okay, if two values are given, it is taken as start and stop. So the default value for start is if no start, if I give a single value, that single value is taken as stop, and the default value for start is 0. Okay, it will start from 0, not 1. And it generates sequence of integers from start to stop. If I specify a third argument step, okay, so by default the step will be 1. That's why we get 0, 1, 2, 3. If I specify some other step, it will iterate in that manner. If I say step 2, then it will be 0, 2, 4, like that. Okay, if step is 3, it will be 0, 3, 6, and so on. And when we specify the value of stop, stop is not inclusive, it is exclusive from the sequence. Okay, so let's run the program here. What did you observe? What are the values being printed here, Disha? Okay, did you
0 to 9.
0 to 9? Okay, so range function generates, so 10 is now the start or stop?
Stop.
Stop value, right? Okay, and is stop included as part of the sequence?
No.
No. Okay, so and do you think this is a collection of values? Is it an iterable? 0, 1, 2,
Hmm.
3. There are multiple values, right? So I can call it a collection. Okay,
Yes, sir.
so for collection you need multiple values, right? Not a single value. This is obviously not a single value, so it can run on this iterable. Every time what it does, okay, this iterator I takes one value from the sequence or this collection, okay, in a serial manner. So first time it takes 0 and prints it. Okay, that is the thing that we have done here, print I. So it prints 0, and also by default it adds a new line at the end. Okay, and so on. Okay, I want to print these values in a horizontal manner. How should I do that?
Uh, we can use end is equal to
End is equal to tab
end.
slash t.
Yeah.
Okay. So if we run this, see this time we get it in a horizontal manner. Okay. Let's look at another example. Okay, let's see. We'll specify a range. Okay, by start and stop. Okay. What would be the output in the second case?
1 to 9.
1 to 9. Okay. Oh, I have to put a print statement here. One empty print to make it print in a new line. Print. Okay. Okay, so can you see here? 1 to 9. Okay. What if I want to print from 1 to 10 actually? I want 10 also to be printed. What change should I do?
I have to use 11 for the stop one.
Yeah. So maybe I can use 11. Okay. Next. Let's see how it works in case of step. Okay. I give it as 2. What would be the output?
So 2 0 2 4,
Try
no,
running
2
this.
4.
Try running this. Try running the code.
I got 1 3 5 7 9.
Why? Because start is 1. Okay, not 0. So since start is 1, okay, it prints the first value, and next time it will go to the value at 2 positions after it. So it will leave 2 and then go to 3. It will print. Okay. Similarly, for 3, if I add 2, it will be 5. 4, it will skip 4 and it will go to 5, and so on. If I want to print even numbers, what should I do? Hmm?
We can start from 0 and then use the
Right.
same thing.
That's all. Okay, you can see 0, 2, 4, 6, 8, 10, like that. So did you understand the different ways in which we can use the range function?
Yes, sir.
Okay, okay. Now, so it is not that the collections that we use should be only using the range function. Okay, we said iterable. It could be any collection. So for I in, I could even do this as well. Okay, print I. So in this case, what do you think will be the output?
Maybe it's position.
Hmm?
I as a string.
Character. Oh, okay. I will give a print so that it prints in a fresh line. Okay. Rather than saying I, maybe you get it confused for a number. Okay, you can give I also. Nothing wrong in it, really. Uh, so I can use some other name for character in Disha. Okay. Where did it go? Which program? Oh, sorry. Print ch. So can you see this? You can even iterate over different collections. We will see list and tuples also later. Okay. There also we can use the for loop. Okay. So what did you observe and understand from for loop? When do we use a for loop?
When we need to use it for a certain range,
Certain
like
range.
fixed
Okay. When we
range.
know, when we want to run a task over a particular collection, okay, then we make use of the for loop. Okay. For example, I can print these characters in uppercase also. Like for every character that I encounter, I can apply a function called upper on that character. Okay. So now, see, this makes more sense. Like even though the name was in lowercase, okay, you can obtain the characters in uppercase, something like that. Okay. So here, for every character in the I trouble, the operation that we have performed is we have obtained the uppercase character of that particular character and displayed it onto the screen. Okay. So this is how we can use for loops. Okay. And you can write a nested for loop also. So write a nested for loop for printing that matrix of zeros and ones. It is like your while only, but you can use I and j along with the range functions. Can you try that?
Yes, sir.
For I in range, I will just show you the outer one. For I in range num, you should have read the num. Num is equal to eval of input. Maybe you can write a message there or also leave it off. So here you don't need to set I to 0 or you don't need to increment I. All these operations are not required. For j in range, num print. What do we print here? Same as the earlier
Print,
code. Relation between I and j. We'll use that relation between I and j. I plus
one
j.
I plus
J. Should I write something else or this is sufficient?
mod. Oh, can
Mod.
sorry. The diagonal matrix.
Hmm? No, I said
Is it the diagonal?
matrix of zeros and ones. Zeros and ones.
Okay, sir.
Okay. End is equal to slash t. Okay. For rows, I don't want to print a row. I have to change the default behavior. Make it print a tab after every print statement. After one whole iteration of inner loop is over, what should we do? That would have finished printing one row. After printing one row, what should we do?
And then print with empty thing.
We have to move on to the next line. So for that we use the empty print. Okay. So let's run the program. See, I give 5. Okay. So this gives us zeros and ones. A matrix of zeros and ones. Okay. So for printing patterns and all, you can use for loop as compared to the while loop because it's more concise. Okay, and far more easier. Okay. Okay. So we'll stop here, Disha, for today. Any queries you have?
No, sir.
Okay. Okay then. Yeah. So we'll stop here. We'll meet on Wednesday, Thursday. Okay, 6 o'clock only.
Yes, sir.
Okay.
Yes, sir.
Okay then.
Thank you, sir.
Thank you. Oh, bye.